Hi, welcome back to another video. In this video, I'm going to talk about my deployment strategy, and I'm going to talk especially about my continuous deployment strategy, which I have in place, and how I used to deploy before, and why and how I'm doing it now. This is a very important topic because at this stage, it is very easier to build a version of an application, but it is very difficult to maintain as well as deploy these application efficiently, because as an individual software developer or a software builder, the moat which I have is how quickly I can change things, and how quickly I can add a new feature and fix things, when compared to a huge team with a lot of pipelines and a lot of steps involved. The easier it takes for me to build and then put it out to the world, the more interest I have in building things. So earlier I was following one strategy, and now I've changed it and I'm doing it in a certain way. And in this video, I'm gonna cover about my older strategy, my newer strategy, as well as why I use certain tools, why I prefer certain tools over others. Deployment strategies are very individualistic, and it depends from one person to another based on their taste and use cases. In this video, I'm gonna show my deployment strategy and the reasoning behind how I do it and why I do it. And there'll be a part 2 video of it where I especially talk about observability and how do I maintain it. First, I'll start with responding to a bunch of comments on my past videos and my DMs. The first one is about adding a lot of beginner friendly topics and then explaining things in detail. And from now on, I would take a minute or two to explain the basics, and then go into the topics which I am talking, so that everybody can follow through. The next one is video seems to be a lot longer. That's a constant criticism which I get, and I try to I value everybody's time, so I'll make sure that I explain as much things as possible in whatever time it takes. Suppose it takes 40 minutes, doesn't mean that I am wasting a lot of time in that 40 minutes, and I'll make sure that the content is jam packed and explained in such a way that the 40 minutes is worth of your time. To do so, I did a bunch of preparation for this video beforehand, and I'll make sure that I do the same kind of preparation before each and every video. I think we'll get started. First, we'll see what CI/CD is, because in this video I'm gonna talk a lot about my continuous deployment strategy. And to understand what I'm doing, we wanted to first know that what is an CI/CD. This picture has a bare idea of what CI/CD is. So this is two parts. One is continuous integration and continuous deployment. Both things are not same, and both has its own purposes. First, you write a bunch of code and commit the code. The steps taken and the steps that happens between you committing the code and the code getting pushed to a repository is what we call as continuous integration. And the steps that happens after that, after the code goes to the repo, the code needs to be deployed, right? All those steps comes under continuous deployment. Continuous deployment looks very obvious. You commit certain code, and then the code gets fetched by the server and it is being deployed continuously. But what is continuous integration? Continuous integration has its own place in software development lifecycle, because there are different. Assume you wanted to run a bunch of tests before the code gets committed. Uh, Either you can run the test in the local, or you can bootstrap a sandbox and run all those tests in the sandbox. The second approach of booting up a sandbox and running the test is more preferable, because the environment is always stable and common across all the employees who is committing the code. The another common feature which is in the CI pipeline is linting. Linting is nothing but we make sure that the code which you write is of a particular style, so that you don't differentiate between who wrote the code, and it is uniform across the code base. So we have something called a linter, which runs through the code and make sure that the code style has been followed. If it is not followed, then the code doesn't get committed, and this step is usually is in the part of continuous integration. And sometimes you build an image out of it. Suppose you run in a Docker environment. You need to build a Docker image out of it and put it in the Docker hub, or whatever Docker registry, so that our continuous deployment picks it up. This stage is also happens as part of continuous integration. So continuous deployment is very straightforward. This can happen in multiple ways. Either every time there is a code push in the main branch, you can pick it up, or you can do once in a day, or you can do a manual push, that if you manually push some code, it needs to be deployed. All of these are possible, and it depends on individual team's decision. So now let's dive into what I was doing earlier, and why it was really bad. So what I would do earlier is I'd boot up n different instance. Suppose I have 10 different application, I'd boot 10 different servers and run each application in each server. This is completely fine. If you get that kind of a traffic, that is fine. Maybe in the first day or the second day you get all those kind of a traffic, that is completely fine. But here, what I was doing is I was having each application across different accounts. Why different accounts? Because when you have different accounts, I am from AWS shop, so most of my instances are in AWS, and AWS graciously gives you 6 months of free trial. So I would create multiple accounts and run different applications at different accounts. So I had this headache of maintaining different accounts, and there might be few accounts which have expired the 6 months period, so I need to do billing for all these different kinds of accounts. Um, the the usual right way to do is you have one account and there is one root user and there are multiple IAM users, so the billing is very easy because you just accumulate all those accounts bill together and then you pay once. But because of this strategy, because of my bad strategy of having multiple accounts, it was very difficult for me to accumulate the billing and pay, and it was even more difficult to keep track of which instance is running what in that. Uh, so I had to manually SSH into each instance. So this was first problem. The second problem is how do I do the deployment is, first I boot up an instance and then I SSH into instance. When the to SSH into instance, I need to set up to SSH into instance, I need to set up the SSH key pair, and then the next stage I need what I need to do is I need to pull my code from my GitHub repository. Assume my GitHub repository is private, so I need to have the GitHub key in my instance. After this is set up, I need to pull the code and then run the code there. And to run the code there, I need to write a separate deployment script. I was using nginx from the beginning, so there needs to be nginx, and then the code used to run on the metal. So there is no container strategies or anything. So at max I can run only one application there, so that I need to write the deployment script uh, for it to run. So that would easily take a day to just write deployment script every single time, because each application is different. One time, suppose I built a fast API based application that will have a separate deployment strategy. If I using SQLite, that is different. If I use Postgres, that is completely different. And then nginx is different. I need to get TLS certificate for each of the instance. So you see, the suppose what if the certificate or something got expired, that I need to handle. And more importantly, I need to the every domains which I have, I need to make sure I properly enter the DNS records, and all those things needs to be maintained. A lot of it is common between the first strategy and the second strategy which I am currently following. But the most difficult part is, assume I wanted to push an update. The only way I can do is I need to SSH again into the instance, pull the new code, stop everything, and then restart the server. And I should pray that nothing breaks, because there is no way I could test this up. So, what were the problems with this old approach? First, I couldn't manage all the instance. Having multiple accounts is always problematic with respect to billing, as well as knowing what account to have and maintaining individual applications. Two, it got really costly. Assume I have 10 projects and now I need to boot 10 instance, and I am very sure that I would at max use like 10 to 20 percentage of the CPU at max, the worst case for each application. I am very sure that maybe in the launch month or two, my CPU would hit at max 30 percentage. In every other month, it would be around 10 to 15 percentage of CPU utilization only, and I've been paying money for that waste 75% of utilization. The remaining 75% of CPU utilization, free CPU utilization, I could have utilized to host another 2 to 3 applications. You see, I've been I would spend about $8 to $10 per instance. So roughly about my bill for every month will be about $80. $80 is nothing but as you see, after tax, it comes about 95 dollars. So I almost spend 8,000 rupees in maintaining my cloud cost every single month. As well as there is always miscellaneous expenses which happens when you maintain a bunch of projects, which I could avoid it or maybe run within even 1,000 to 2,000 rupees at max. So this is a main realization that my workloads doesn't need multiple instances. Suppose I finish building my application on Friday, I can release that on Sunday night or Monday morning because it takes that rough 1 or 2 days for me to just write the deployment pipeline and test just the deployment pipeline, not the application, and make sure everything is working. Which is really bad because the excitement of me building an application just drops drastically because it takes another 2 days for me to put it out in the world and see people use it. I have assume I have about 12 different instances. About 30 to 40 percentage of the deployment code is common among 12 instances. You see, I'm just repeating the same thing again and again for different instances, which is really bad. I already have my Raspberry Pi running every day in my home, so I wanted to use it as a staging instance before I push the code to production. Doesn't mean I am just testing all the features, everything is working or not. But it is always nice to experiment things on my Raspberry Pi before I put it on my AWS instance. So these are the 6 reasons why I decided to move away from this strategy and build a robust strategy for me to ease out this deployment. I came up with this design for myself so that I could efficiently do my CI/CD, at least CD, because as of now I'm not too interested in my CI. I would just add a GitHub Actions sometime later when I need it. At this point, I don't need, because I have a bunch of make script and I run those script, and that is good enough for me as my CI. So since I'm fed up with managing these multiple instances and everything, I wanted to make sure that every non-paid application will be in one huge instance and will be running inside one huge instance, and all the paid application will have its own small instance, and I would monitor it for a while, see how it performs, and I mostly keep that outside of this huge instance, because the disadvantages of hosting in one huge box is, if suppose there is one small fault in that box, everything goes down. So all my paid application or the application which people use after paying some money, that is in separate instances. The cool experiments which I wanted to do, which I wanted to put out, I would boot a huge instance and then put it there, because I don't care if it goes down, I will always boot it up. So to deploy multiple application and isolate them, I decided I will use Docker throughout. So the moment I decided I will use a Docker throughout, I had variety of options like Kubernetes, and then a Docker Compose, managing everything through one single Docker Compose, writing my own bunch of scripts and managing those Docker containers. How do I route traffic? Just to route traffic, I had very different options like nginx, HA proxy. I went through traffic. I saw caddy, and lot more. There's two different parts which I need to pick for my CD. One is the reverse proxy which I'm gonna choose, and then the other is how I'm gonna do this continuous deployment, either through a bunch of scripts which I run in a timely manner, or through a webhook from GitHub to my server, or pick up an inbuilt tool which does the same. First, I needed to pick a reverse proxy, and the common options which I went through were nginx, HA proxy, traffic, caddy. These were the four different reverse proxies which I was looking into, and I wanted to pick one. So I picked nginx over all others. I was finally oscillating between nginx and traffic until I saw this tweet by Sam Lambert. Don't know who Sam Lambert is. He's the guy behind Planet Scale. Planet Scale is one of the most no is one of my favorite products out there, and it's one of the go-to standard products for database services. Sam Lambert used to work in GitHub back in the day, and this is the tweet he tweeted exactly at the same time which I was thinking about choosing between nginx and traffic. So until 2015, GitHub pages hosted over 2 million websites on two servers with a multi-million line nginx.conf edited and reloaded per deploy. In nginx, what you do is you need to fill a config called nginx.config with all kind of rules and how do you want it to route the traffic, or if you wanted to use it as a load balancer, or how do you want it to route it. And it has bunch of features which you can which everything needs to be configured in that nginx.config. Basically, this nginx.conf is the source of truth, and based on that nginx.conf, the whole configuration works. The modern tools like traffic and caddy tries to reduce this insane amount of configuration which needs to be done, as well as they tried to nginx.conf is an separate is an the syntax looks a bit different, where the in traffic use a more common syntax like toml, and then caddy has its own syntax which looks a lot simpler, and nginx has a huge learning curve before you can efficiently use that. The mode of the newer reverse proxies are to reduce this setting up overhead of nginx and make sure things are configured really easier and simpler. But nginx is the goat. Nginx is the battle tested reverse proxy. Nginx have additional features over no you can not just use it as a reverse proxy, but they have way more additional features. Even though nginx are not natively no Docker supportive or cloud supportive, you can always do all those things and configure them, because nginx is a bare minimum slate in which you need to configure whatever you want. So what he says is until 2015 there were about 2 million websites, and which websites on two servers, where they would just go fill in this nginx.config and then reload the nginx server, where GitHub ranked as 140th most visited domain at that time. So what he tries to convey here is you don't have to have an very complex or very modern tools to do the bare minimum things which they used to do for years and years and years. And all these tools are battle tested and it's been used by a lot of companies over a lot of years. Why do you need to complicate things and use newer tools when the existing tools works really well? But just that it just has a little bit more of a learning curve. Plus, if you use these existing battle tested tools, you would definitely fall into some mistakes which were already which people would already face years and years ago, so that you could easily find solution out there on the internet, rather you go making new mistakes and make your life more miserable. So for this reason, I just went ahead with the nginx. So let me compare between all the tools which I wanted to pick. The first advantage of nginx over HA proxy is HA proxy is a really good tool if you wanted to do if you wanted to extensively do load balancing. But nginx also supports load balancing, but HA proxy is the gold standard of doing load balancing. But here I don't need that kind of a load balancing performance or anything related to load balancing, because when I wanted to do some kind, if I ever wanted to do some load balancing, I could always do it with nginx. And then nginx also has this additional advantage of static files rendering over which is not possible in HA proxy. And nginx also has this no from the server you wanted to serve a bunch of files. Nginx allows you to gzip the file, natively gzip this file and put it out, which is not possible in HA proxy. I think it is possible, but the configuration is little difficult. Plus, people say nginx is difficult to configure, but HA proxy is even more difficult to configure and set up. That's the reason I preferred nginx over HA proxy. And then traffic and caddy. Traffic and caddy comes into the same realm, but the advantage that traffic gives is it is Docker native, Docker pod, whatever, or container native, so that it just manages containers way more easily than nginx. uh, suppose a container uh, Suppose a container goes down, or if you wanted to route container configurations, route from source to another container, and and if you wanted to know the health check by default, suppose if you wanted a dashboard on how these containers perform and what kind of traffic which is coming in and all those things by default, those things are available in traffic, which is not available in nginx. But one major advantage which I felt traffic is better than nginx is by default TLS support. So by default it allows you to know, if you just connect a container with a web server, it just by default provides you with a let's encrypt certificate. But in our case we need to manually set up the certificates, so we need to know set up the cert bot and everything. Despite this, nginx is way more performant than traffic, and traffic is nginx is completely open source, whereas some parts of traffic comes under this enterprise plan, like this dashboard and everything. So everything what traffic can do, even nginx can do, but rather we need to set things up. Like example, for dashboard I will have my own grafana Prometheus dashboards. Then for TLS, it's a one-time setup of setting up cert bot and making sure I issue certificate for every application. So all these things are anyways possible, but it is on one-time overhead. So I went ahead with nginx. So now let's discuss about the architecture which I followed. Because a lot of it involves you not paying a lot of money or any money in setting up. And the other main goal I had is no, it needs to be very simple and not too complex. So I was thinking, how do I do my continuous deployment? That is, just pick the code from GitHub and then deploy it. So the first idea which I had is, the moment I push to GitHub, I will have an no GitHub action that will trigger an endpoint to my server with an authentication token, obviously. And if the server will keep listening to this authentication token every second or so, and if it receives a request from my GitHub actions, it will pull the code and do its thing. It is a straightforward script to write this, but I didn't go ahead with this because I found out an open source tool called Woodpecker CI, which exactly does what I told, and it has an additional features of a super cool UI to look at things and then do the setup and everything, see the pipeline running and everything. So instead of me writing the same scripts, they have this beautiful no setup of what exactly I am telling now. Just when you push it to GitHub, this we trigger this Woodpecker CA, and then Woodpecker CA just pulls the code. So I went ahead with using this Woodpecker CI. It is open source. It's been there for quite a while, and it is a very small application. So I understood what exactly they're doing. So I used them over manually writing the bunch of scripts. So okay, first what happens is, so this is the N network which I wanted to set up, where this N user would reach out to my server, and I would only expose 443 if it is production, or 443 is HTTPS port and 80 is HTTP port. So when I am testing it in my Raspberry Pi, I will expose port 80, and if it is production, I would expose port 443. So what happens is, when an end user of this n different application which I have, so I would map it in my DNS settings based on my host name or whatever, and everything will point out to this instance, and nginx will make sure that I based on the request that comes in, it'll redirect the request to one of the instance over here, and all of the instances are in the same Docker network. The reason why I have all of the network in same Docker network is, you could directly yeah, suppose this Docker container names A, B, C, D, and E. Since everybody is in the same Docker network, each and every instance, including this nginx. Nginx is not in the host. Nginx is also in a container, running in a container under the same Docker network. The reason why nginx is running in a Docker network is because since all of these containers are running under the same Docker network, each one can identify one another. So the writing the nginx config is a lot easier, where I just need to say yes colon no 8080. That means the request which comes in from this URL will directly go to this AS 8080. This simplified way of identifying the instance is what traffic offers as one among its feature, because since now everything is in the same network, internally what happens is, even though you do this a semicolon 8080, this Docker network no maps this with some unique internal IP address of Docker. So this routing happens smoothly. Initially when I there is a fresh instance, assume there is one huge instance I am gonna boot up for the first time. So assume this is my local laptop, and this is one fresh empty instance, nothing is there in that instance. I need to set up two things here. One is the woodpecker containers, second is the nginx container. So for this video I'm gonna do a small demonstration where in my Raspberry Pi I'm gonna host two different applications. One is the woodpecker server and another is a simple Go application, which I will show you now. So I have a simple Golang application which just prints hello world, hello Go world at port 8080. And I have a Docker compose file here, and then I am putting it into this network called infranet, which is common. Every container will be under this under this network called infranet. Okay, so this is a very simple Docker file where I'm doing a multi-stage build here. Nothing but I'm just running this no, Golang file inside an Go container. That Docker app is our test app there. And then assume there is assume we are going to boot up this from scratch. So we have one instance. Assume my instance is my Raspberry Pi. We have one instance. We need to boot up the nginx container as well as the woodpecker container in the first place, and then we will do an cd in deploying our that Go app, which just prints hello Go. The most difficult part which I had here is managing my environment variables. Usually what happens is, in organizations we all use secret manager to manage all the secrets. That is the right way and the efficient way to do it. But here I wanted to just use .env file. I can't just commit my .env file because no you can't commit your secrets, right? So there needs to be a way to efficiently move my secret from my server to from my local to the server. What are the secrets here? There are there are three different environment variables which I need to set. One is the base environment variable, where this env is used to SSH into the computer, identify the GitHub repo from where you are going to pull the code. This is the repo which I am going to pull the code. And then suppose your SSH involves key based SSH, you need to be mentioning the path of that, and then the basic SSH URL. And then there is one secret key which I will come to it in a bit. And then there is another and then for setting up this woodpecker CI, you need to set up bunch of environment variables. How I've designed it is, for the first time it takes .env, and we use this secret here to encrypt this woodpecker secret which you have written, and then it will push to the GitHub. You can see this woodpecker dot encrypted, right? So since the secret is encrypted, nobody can read the secret, and you need the secret key to decrypt here. So now my GitHub has all the woodpecker secrets in form of encrypted file. So now my instance will pull the code, but it needs to decrypt this the secrets for it to use in the application. So as part of the bootstrap process, what I do is, from my laptop I run a script which just SSH into this instance and uses this secret key, which is the secret which I use to encrypt. So what it does is, it just SSH into the instance, pull the code decrypt the secrets, and then run the Docker compose file to set up my woodpecker agent, woodpecker server, as well as my base nginx file. So my base is set up: woodpecker server, a woodpecker agent, and the base nginx. So the next part involves how do I manage my different configs. Assume now the base is set up. Now I want to create a new file here. So or I need to commission a new app here, and that is done through two-step process. One is we need to make sure that we update our nginx config. So in this nginx config, what I did is I wrote this. So when it hits hello, it just proxies to my GitHub container hello go app in port 8080. I write an nginx config which points to the hello go app container, which is the container which I'm gonna run from into the server. The go code which I showed, right? That container is called hello go app. So what I'm gonna tell nginx is for this location, if I get slash hello, just proxy pass to this containers this port. You can completely write a new config and just change the server name. So you can differentiate between different configs based on the server name, and just you can just say like example void.com can if the no input sorry, if the request comes from void.com, you can go to this root location and you can write a different config which comes from void1.com. Also you can make sure you can write the same location is equal to root location. So when it comes from void.com, it just goes to this root, and if it comes from void1.com, assume this is void1.com, it can go to the same slash route. So here I just have only one server name, that is my local Raspberry Pi. So for that I'm making sure that everything which comes from this IP address, local IP 192.168.0.112, if it is slash, it will go to the woodpecker server. If it is test, I'm printing something else here. If it is slash hello, I will now redirect to my container. So now every time what I need to do is there has to be two CI/CD for our case. One CI/CD is for my Go application. So any change in the Go application, my CI/CD needs to pick up or manually trigger. And another CI/CD is for this repo, because every change in the nginx config, what my server needs to do is needs to pull this nginx code and then reload our nginx config with this latest config. So how woodpecker work is we just write something called woodpecker.yaml, and then we need to write a bunch of steps here. So what I'm doing is I have a manual trigger, because I don't most of the time I don't create branches and work on it, because I push everything to main, because I'm just the only person, right? So I don't want it to pull the code and build every single time. So I have a manual trigger here, so which I will go in the UI and trigger. So and then similar to how you write Docker Compose, this is a multi-stage build. Basically, what I am doing is I am going to just after pulling the code, I'm just going to do Docker Compose nginx yes reload. If there is no nginx no container running, I would do this Docker Compose up for the first time. Else, in most of the cases, some nginx is already running, and now my by default woodpecker would pull the code, and all I need to execute is docker exec nginx reload. So you can write whatever no commands that needs to be run in this .woodpecker nginx file. So the moment the nginx our woodpecker's server sees a change in our GitHub, it just pulls the latest code. Or suppose we have, based on the trigger which we write in this when, so here it is manual trigger. So what happens is when we manually trigger, it just checks this woodpecker YAML and just executes these steps here. Here all I wanted to do is reload my nginx config with the latest config. That is, the latest config is a config which has this hello world hello app added. There is only one time SSH, which also you can prevent. The reason why I'm doing this one time SSH is to just pass on the encrypted pass on the secret to decrypt, which you can always add it as a part of GitHub secret, in your pipeline and then decrypt it there. I wanted to make things a little simpler, so I did this way. So after the first configuration, I don't need to ever go into my system at all, because I could manage everything using this Woodpecker's UI. So what I am doing now is I just SSH into my Raspberry Pi. You can see as part of bootstrapping, it just bootstrapped nginx and then the Woodpecker server and the Woodpecker agent here. And I could see I was already testing, so I just added two repository here. One is our repository, infra repository to change nginx, and then the other one is the Hello Gold application. It's just very simple, just add the repository. Since we have synced with our GitHub, all the GitHub repository shows here, and then we can just enable whatever the repository which we want to be added the pipeline. So this just two step. One step is just adding the repository, and another step is writing the .woodpecker file. So the moment you add a repository here, for example, this hello world app here, so all you can do is, since I've added manual trigger here, I just need to just run the pipeline, which will just pick up the woodpecker.yaml file from our repository and then run that. You see that the pipeline runs, and this is the advantage of using tools like this. Instead of me manually writing, I won't get this yeah, super cool easy UI. So it also lets us know what exactly the problem has happened. You could see there is a problem with docker hyphen compose. So if I don't have this UI, and it becomes really difficult for me to debug. Now I understand the error from the error log, so I can just rerun the pipeline, and immediately I will see what exactly is going on. So first it just automatically pulls the file, and that we don't have to do, and then you see it has built and deployed the container as well. And now if you remember, in our nginx config, we've configured that under hello, if you just type this hello, it will just redirect us to the this new hello go container. You see, we have successfully got our output as go hello go world, so it is successfully redirecting it to our container. So think of me doing all the stuff for like 2-3 days, and now all I need to do is just fill in a bunch of config and wherever I need, and I will complete my work within a hour. So since it is local, I will use it as my staging instance and check if my deployment is correct, and then I will move the version. And then once everything is correct, I will just click this run pipeline to my production infra, and then it'll all do its work. I didn't talk about observability and logging in this video. I will talk about it in the next video. The main idea of making this video is to give a high level overview on how to set up your own CD. I think this video was very insightful. I will see you guys in the next video. Thank you.